So today we're going to look at molar volume conversions, but before we do that, I want to review what we've already learned and what's in our toolbox, okay? So at the top of your page, write toolbox. And this is what we're building as we go with the tools that help us solve the problems. So the very first thing that we learned was mole ratios. And we use the coefficients of the balanced reactions to get us from moles of one chemical back and forth to moles of another, okay? So this gets us from moles of one thing to moles of another. And we get this from the coefficients of the balanced equation, okay? The next thing we did, which was yesterday and for the warm-up, is molar mass, which gets us between moles of a chemical to grams of the same chemical. All right, but we know that there's another way to measure, and that's what we're going to do today with volume. So, another way to measure is through volume. But when we talk about this today, we're only talking about gases. So this can only be done for gases. So we're only talking about that particular state of matter. Like oxygen gas or nitrogen gas or helium or neon. Okay. Carbon dioxide, carbon monoxide, anything that's a gas. Through experimentation and lots of experimentation, it's actually found to the relationship between the moles of a gas and the volume of a gas is a known number. It's like almost like a constant, okay? So it has been found that 1 mole of any gas occupies 22.4 liters of space at what's called STP. 1 mole, 22.4 liters of space. So we could take any gas, and as long as its conditions are at STP, it will occupy 22.4 liters of space consistently. So then the question is, what is STP? Okay, so turn to your neighbor. If you had to guess what STP was, what would you guess? Any guesses? Yeah.
Surroundings, temperature, pressure.
Okay, you're so close. Good. STP is standard temperature and pressure, okay? Have you ever had a balloon, like held a balloon or seen a balloon on a hot day? What eventually can happen to the balloon? Couldn't it like pop? Okay. Well, that's because when we change the temperature or pressure of a gas, it changes its volume, okay? And so in order for us to say for sure that 1 mole of a gas will occupy 22.4 liters of space, we have to hold the temperature and the pressure constant. And so when we hold the temperature and the pressure constant, then that means that we can actually look and measure the volume and then compare gases as long as the temperature and pressure of all the gases are the same. And so that's what's called standard temperature and pressure, or STP. So standard temperature and pressure. So standard temperature is 0 degrees Celsius. And standard pressure is 1 atmosphere, ATM. And you may not be familiar with that unit, but it is a unit of pressure. Here in America, what unit of pressure do we use? PSI, which stands for pounds per square inch. That is not used in science at all. We use atmospheres, and there's a bunch of other pressure units like torr, millimeter mercury, and kilopascals. Kilopascals, I'd say, and atmospheres are used the most. Okay, so all we need to know is that when we are dealing with stoichiometric or stoichiometry problems right now, as an introduction, we are going to be at STP. So the gases that we're dealing with will be at STP, which would be 0 degrees Celsius and 1 atmosphere. Okay, now that can change. That can change. Okay, but for right now, when we're looking at a gas, it's going to be at this. Yeah, question?
What if it's not a gas breaker?
If it's not a gas of that temperature, then you can use the combined gas law, and then you would do P1, T1. There's a whole equations for that. There's also ideal gases and non-ideal gases, so there's a lot more to it than just this one. But for learning the introduction to stoichiometry, we're sticking with the STP. And so there are other equations that we cover in AP Chem. So if you take AP Chem, then you'll learn about what do we do when it's not at STP. Okay? Okay, so what does this mean then in terms of our ratios? And how do we use this? How do we use this knowledge that 1 mole of gas occupies 22.4 liters of space? Well, it's a ratio, okay? So I can say 1 mole of any gas occupies 22.4 liters of space. It's a ratio. Or I can say that 22.4 liters of space has 1 mole of gas. It's a ratio. I can write it either way. Okay, the same way we could say moles per gram or grams per mole using the molar mass. Right, so let's look at an example then. How many moles of N2 gas is contained in 120 liters at STP? Probably should say are contained. How many moles of gas are contained in 120 liters at STP? Let me fix that real quick because that's going to bug me. How many moles of N2 gas are contained in 120 liters at STP? Okay, what are we given? 120 liters, and what are we trying to find? Moles, and we're looking with N2 gas, and we are at STP. Okay, so I'm going from liters to moles. So step 1 is going to be set up a train track. My train is what I'm given, so 120 liters of N2. Okay, next step, I'm going to copy the units down so that they cancel. Liters of N2. And then what units am I looking for? So moles of N2 would be on the top. So now I need to think, okay, what numbers are going to go where? So I need to think about this ratio and where I put what. So what number is going to go on the top? 1 mole, because it's 1 mole of any gas at STP will occupy how many? 22.4 liters. It's always going to be 22.4 for 1 mole at STP. Liters N2 cancel with liters N2. What mathematical function do we do across the top? And on the bottom? So divide on the bottom. So 120 divided by 22.4. When you get an answer, hold your calculator in the air. All right, what's this answer? What?
Mole for the 6 mole.
5.36 mole N2. Okay, so if I had 120 liters of N2, I would have 5.36 moles of gas in that space. Okay, let's do one more, yeah? Here we go, one more. How many liters does 4.6 mole of NH3 occupy at STP? All right, I'm gonna give you a bit of time to solve this on your own, and then we'll come back and solve it together. All right, let's go ahead and solve this one. So, how many liters does 4.6 mole of NH3 occupy at STP? What are you given? Of NH3, and what are you trying to find? Liters. So we're going from mole to liters, and we are at STP, which means that I can use my molar volume. Okay, so step 1, train track, 4.6 mole NH3. Now what? Copy the units down, mole NH3, so they cancel, and what units would go on the top? Because that's what I'm looking for. So now I need the numbers. So 1 at the bottom, and what's on the top? Good, because 22.4 liters of any gas is contains 1 mole at STP. Anything cancel? Mole NH3, moles NH3. If it's on the top, what mathematical function do we do? Okay, so 4.6 times 22.4 is? There it is, 103.04 liters of NH3. Perfect. And that's it, molar volume.